Hello there. So, telemetry, streaming telemetry, artificial intelligence, machine learning, all those are fancy and fashionable buzzwords these days. However, if we look at the scope of BGP, BGP is sadly left aside. Who of you have heard of artificially intelligent streaming BGP telemetry with assistance of machine learning? So this needs to be addressed somehow. Well, let's do that one step at a time. So BGP telemetry. What's telemetry? Overall, it's a mechanism of observing, monitoring some properties of some abstract entity, and generally doing that remotely. This is not a new concept overall in engineering, and not a new concept in telecommunications too, especially the data plane telemetry. Many of you are well familiar with that. So things like NetFlow IPFix, that's widely used and accepted in the industry as a standard. Another thing, what we see in the industry is a move away from move away into push-based mechanisms, away from polling, where your management systems or some other entities are querying your network elements into the mode where the network elements themselves are informing of what is happening with them and the events that are happening there. All right, what's BGP? So BGP, wait a moment, I think I'm in the wrong room here. What's BGP telemetry? If you look at the operation of your BGP sessions, they mostly work for the biggest part of the time, and you might even think that they work all the time. However, are you certain that they are working in the way they are supposed to work? Are you certain that your routing policy is operating the way that you want it? Do you actually see all the events, malicious or unintentional events, which are happening within your network? And do you have cross-vendor mechanisms for insight into these types of happenings in your network? There's a multitude of different, say, fragments which address portions of the problem space. MRT is probably, multi-threaded routing toolkit probably is the most widely used. However, those are files, and then you can post-process them more or less semi-offline. There are SNMP traps, there are other transport mechanisms which provide equivalence of SNMP traps. There's a trend into the modeling, and modeling can provide you the operational state out of the devices. There are proprietary mechanisms, as a rule, based on a command line, and therefore this comes into the problem space of not being uniform across different vendors. Certainly we could have something better here. One of the options is that we can try to use BGP for monitoring BGP itself. So basically run a dedicated session into what you might call a collector or analysis node, and do an advanced analysis there, typically as a rule using available open source or commercial platforms which are meant for that. However, there are certain limitations, not necessarily problems, but limitations with that. A BGP session provides what gets out after the policy processing. Even if you don't have policy processing, BGP selects what it thinks as a best path. Yes, you can have multi-paths and things like that. However, that's at least a partial reduction of the visibility that you might have. You might do monitoring on the reflectors and might deploy dedicated reflector nodes only for these types of purposes. Yes, this can be made to work. However, again, we can try do something better. Overall, telemetry and streaming telemetry in particular is not a new concept. Data plane is using that for a long time and using successfully. There are some attempts of using equivalent ideas from for the control plane perspective. So let's look into what is possible and what can be made to work for BGP. BMP, BGP Monitoring Protocol, a dedicated protocol defined quite a long time ago. It's over 10 years right now. The specification is fully complete. There are multiple shipping implementations of that. So first thing, this is not an extension to BGP. This is a separate, standalone, simple, and some of you might even say that a dumb protocol. A unidirectional, going only from a network element to the collector side, so you don't need to be afraid that somebody will send out something and your precious router will fall apart. It uses the pushing model in a sense that if events are happening, notifications are sent out proactively or based on some timer. There is no need to pull from some central entity or some management system and ask every time, dear router, please tell me what you are doing there. It's a binary protocol. And made efficient for the implementation on the generator side, on the router side, with a certain drawback that this might have a slightly higher cost on the collector side and the interpreter side, the user side. The reason for that is quite simple. The router has to do its work to calculate the topology and not do pretty formatted JSON encoding. This is something that your manageability system should be working on. The end result of all of this is that you have much better visibility into what your BGP implementation and policy on top of that implementation is doing. So how does that work from a high level? There are a few classes of events or groups of information that can be generated depending on what is happening in a time frame of processing of BGP updates. And the overall approach is feed as much as you can, absolutely everything without thinking into the collector. The more the better, and let the collector analyze and throw away what is not needed and process that information. Overall, the BMP feed has within itself enough of information to replay the events which were happening in your BGP session fully and independently. So this is a rather big step forward from the MRT-based approach, where you need to know whether your AS path uses 2 or 4 octet ASs if you have add path enabled or disabled. Do you have certain address families enabled or disabled, or so on. All of that is contained natively in the data that is provided by the BMP. So, mirroring. A mechanism of taking the message before processing by the BGP component, just as it is received on a wire, and also before it is sent out on a wire after the generation. What it allows is to detect malformed, intentionally or unintentionally malformed BGP messages. And it allows for seeing in a machine-formed and more or less unified way problems like malformed attributes or some forms of attacks based on that. So actual real-life horror story. You might even today, you might put quite many of BGP implementations into out of a resources state by sending carefully crafted updates, which are intentionally made inferior to the best path, but each of them having different sets of attributes. So that update will not be seen as a best path. If you are monitoring the stability of prefixes, you will not notice that. However, if you are successful and if you do some experimentation, and if you are familiar with internal implementation of your particular vendor's BGP component, you might, with a rather small number of updates over time, push your BGP implementation into severe resource leakage. And yes, those attacks have been seen in the wild. Today, not that widely, but there are still implementations which are commercially shipping, which are still susceptible to these types of attacks. BMP will quite happily, mirroring of the BMP will quite happily allow you to see those attacks happening, as you will see the incoming messages before the actual processing. Events. Pairs going up, down, negotiation problems, why session is not coming up. All of that information is recorded and sent out as a separate class of events happening on a BGP session. Also, this includes some information about the actual BMP component, whether it's overloaded, whether it lost some information, and things like that. Monitoring, probably the most valuable functionality of BMP. It allows you to see the events and attribute changes related to the prefix. So per address family, visibility into what is happening as your prefix gets propagated. There are several attachment points, let's call them for simplicity. So prefix before the incoming policy, prefix after incoming policy, local RIP, and prefix before outgoing policy and prefix after the outgoing policy. And it allows you to see how the attributes are being changed, whether your incoming or outgoing policy works in a correct way, and you receive or send out what you are expected to see. And the other important functionality of this is that this is encoded as the actual BGP message sent out to the monitoring station. Therefore, if you already have the tooling which is able to parse the BGP feed, the changes required for adjusting to BMP sessions are not that large. Within the BMP packet, it's kind of a tunneling mechanism. Inside you have encapsulated, fully legally encoded BGP message. Statistics. Various counters, how many prefixes you have received, retained, sent out, advertised, how many were filtered, for what reason, whether that's a policy-based, whether that's some form of BGP processing, like a loop, malformed attributes, and things like that. Counters are sent either periodically or based on events. This is all based on the nature of those counters and also implementation details. How to use all of this and what can it give to you? So you need two components. One on the router side, which is called a generator, which generates or kind of translates the BGP events into the BMP stream. And then on the collector side, you need another component which is able to receive, process, store, and do whatever you need with that. There's a healthy support both from a commercial and open source side. Most of the credible vendors today support BMP as default. Well, if some vendor today doesn't support BMP, probably that's a first sign that you should not consider that such a vendor too seriously. From the collector side, overall support from the open source community is strong. Panda and PMACT probably would be two, largest and most widely used implementations, with a majority, with quite a large number of others, and this number is increasing. Overall, from an industry perspective, we see rather strong signs of acceptance of this. Many of the operators of different types, IXs, transits, even enterprises, are looking into that, and many of them are trying to use that as pilots. Many are looking into kind of a read-only mode, experimenting with all of that. Again, from a vendor perspective, BMP appears to be the interface into the BMP operation. And many of the vendors have plans for prioritizing BMP over their proprietary event interfaces. From a perspective of usability, one thing that you need to be aware if you start looking into deployment of BMP, that this mechanism may provide you redundant information. That means you may receive certain events multiple times, same equivalent events multiple of times. There's a multitude of reasons for that, many of them related to implementation aspects or in, say, implementation efficiency. because the router itself needs to do its job to calculate the topology and not necessarily deal with the pretty formatting of the updates. Therefore, it's much easier for implementation to send out portions of information at different times than full say, unit of information collected at the same time. Therefore, you might receive multiple updates for the same prefix having different modified attributes because they are being processed in a different time in a BGP pipeline. So, questions, all those questions which you wanted to ask but didn't have patience to wait for the microphone. Let's run through at least some of them. So why this is a binary encoding and not my favorite JSON, XML or something else? For efficiency, for encoding efficiency and transmission efficiency, BMP may result in a really large amount of data being sent out, encoded and decoded. Therefore, binary protocol is much more efficient for that. What happens if I lose my BMP session to the collector? Well, for the operation of your network, nothing bad happens. BGP will continue to run as it used to. The only thing is that you lose visibility into the events. Now, it's an implementation aspect whether the router will buffer those events which it is unable to send right now or will simply throw it away. In general, most of the implementations will just drop them. Again, this is a question of resources and question of priorities. Now, and if you are dealing with, say, accounting systems, if you're planning to charge your customer for the number of BGP messages that you received from them, well, this might be a problem for you. However, if we are looking from a practical point of view, as a rule, you have multiple BMP collectors, and losing all of them is not very likely. If you lose the node, probably you have far bigger problems than losing telemetry information from that node. Is BMP lossless? In a sense, can BMP lose information by itself? Yes, that can happen, and again, you need to be prepared for that. This is again the topic of resource allocation and partitioning. It might be that BMP component is not able to encode or send out all the changes which are coming in the instance of, say, large topology change. Very simple thing. Well, this is elementary laws of physics. If you have 1,000 BGP sessions, and if you want to feed all of that information into one BMP session going to one single collector, well, it might not fit there. Therefore, it's perfectly legal for BMP to drop certain things, maybe prioritize more important events, and possibly recover or not recover. You need to be ready for that. Can we run normal BGP session to the collector instead? Well, this seems really complex. Well, certainly you can. If you understand that you might lose fractions or even bigger portions of topology visibility, yes, certainly you can do that. Is BMP deployed at all? Yes, deployed. And the number of deployments and the breadth of deployments is increasing, certainly. So, I'm a highly certified network engineer. My BGP sessions are stable, work perfectly fine. I can type in commands, woken up at 2 a.m. in the morning. Why do I need to bother? I'm certainly happy for you, but do you really have visibility into what is happening on the ingress of your peering sessions? Do you have visibility into how your routing policy operates? What if something somewhere happens? Do you have the visibility of how the changes propagate through your network? Maybe you do. But BMP might provide you that visibility probably in a much simpler way. Why BMP is not YANG-based? For exactly same reason, and overall, while not model-based, for exactly same reason why it's not pretty formatted JSON for efficiency on the wire. Can I use this fancy BMP thing to protect against all sorts of hijacks, attacks, and other things? Well, this is a tool. By itself, it doesn't do anything at all related to attacks and hijacks. It can be used as a source of information of what is happening in your network. If you start receiving advertisements of a prefix with wildly different attributes from multiple sources, that might be something to be worried about that. But this is not a job of BMP itself to try to address these types of problems. So this appears to generate a huge amount of data. Indeed, yes. So if you're, for example, trying to do both mirroring and monitoring pre and post policy for inbound and outbound policy, you will get on average 6 times multiplied the number of information, and that's a very optimistic estimation. It depends on implementation, it depends on your policy. The amplification factor sometimes might be several magnitudes, and yes, you need to be prepared for that from a deployment perspective. So, a discussion. If there are any other remaining questions, please. So a couple of those that I would have interest from my side is if you are already deploying it, what's your feedback? Is there something missing fundamental from a protocol mechanics, from a, say, functionality of the overall BGP telemetry architecture? If you're planning to deploy that, what is missing? What would you like to hear or find out about that? But everyone is happily using that. Perfect. So one note from the, say, deployability status and overall whether this thing is workable. It is. It's around 15 years for this idea. From the specification point of view, it has been finalized around 2013-14. Pretty much every vendor is shipping implementations. Implementations are interoperable. There are regular interoperability events happening at IETF meetings. And the feedback from operations community is that this is the right thing. It's ready for deployment. Right, fine. Thanks, then. I'll probably go and deploy BMP somewhere. Great, thank you.